Okay. Well, I'll start off by talking about collections counter. I love this little gizmo. It is a tool for making rapid tallies or counts of data. It was modeled after multi-sets in C++, bags in Smalltalk and Objective-C, and I looked at another of other implementations before putting the counter together. It's incredibly flexible because it's basically a dictionary implementation with just some additional convenience tools attached. A little bit of an echo. Good. So it's wrapped around a dictionary, so the capabilities of a counter are basically whatever a dictionary would do. You've already got that with a counter. You can do anything with it like a dictionary. You can stick anything inside it. Positive numbers, negative numbers, strings. Strings don't count very well, but you can stick anything in it. There are no enforced internal invariants. It's just a dictionary. So to emphasize, the point of this slide is you can do anything with a counter that you can do with a dictionary because a counter is a dictionary. And the design is it's just a simple dictionary subclass. We've added a under missing method that returns 0. And what that means is you can use a style, this tally style of, say, C of X, some key, plus equal 1, and you don't have to worry about whether X was already in the dictionary or not. If the key was missing, it will presume the initial count is 0. And we could have stopped with the design right there, and you would have had a very useful counter. So counter is simply subclass of dictionary with an under missing that returns 0. One extra embellishment was also modified del item to match missing so that you can try and delete something from the counter that is not there, with the idea being, say, remove all Martians from my set. Well, if there's no Martians in the set, you're not going to get a key error back. It'll just make sure that your count is effectively 0. And these things are just designed to make counter a little bit easier to use. Things that in the past we used a get for, or we do a look before you leap approach of looking in the dictionary to see if an object was there before counting. Okay, excellent. And so the basics of the implementation are we subclass from dictionary, define a missing method that returns 0, and define del item that checks to see if the item is there first, and if it is, it deletes it. And so if you were to roll your own version, if you're not on Python 3.2, if you were stuck back in Python 2.5 or 2.4 land, this would also work. Actually, I think under missing might have been added in 2.5, but this short recipe is enough to roll your own counter. And the way it's used is demonstrated at the bottom. We do a series of tallies. You can, +1 is the most common tallying technique, but you can add 2, add 10 items, subtract. You can do any adjustments. Remember, it is just a dictionary, so there's no magic to this syntax. You can see when we display it, the fourth line that says C, it just displays the contents of the dictionary, and the dictionary has the item and the count for each item. And then on the last item, I give an example of deleting a key that's not in the dictionary, and notice you don't get a key error, so it's very simple to delete something out. Okay, so I'll give you a couple examples. Let's say you're building some type of unit test suite, and you want a result counter. Instantiating it is easy. Just empty counter, open bracket, close bracket. Loop over your test, run the test. If the test succeeds, add 1 to the result. Notice you don't have to do any checking to see if the I've succeeded already exists. The initial count is 0 automatically for you. So it makes it a little bit more convenient to use than regular dictionaries. And then regardless of whether the test succeeds, you record a count for the number that's attempted. So not a terribly exciting example. One a little more interesting is doing a word count. And the example I give in the documentations was written, went to the Gutenberg project and downloaded the source for, or the text for Hamlet. And with just these few lines, we're able to open the text file, read in all the text, lowercase it, use a regular expression to break it into words, and drop the words into counter. So this is kind of nice. The constructor for counter will take a list and loop over the list and count them all for you. So that's a nice little convenient function, and I'll show you that on the next page. And another convenience item is a method has been added in addition to the regular dictionary methods. We have most common method. So most common 50 will give you the 50 most common words in Shakespeare.text. And I think that makes for a beautiful little snippet of code. That is how you use it. Okay.
Raymond?
Yes.
Can you clarify the difference between this and default dict?
The question was, can I clarify the difference between this and default dict? They're amazingly similar in their implementation. With default dict, lets you supply several different types of functions. It gives you a choice of a constructor function. So a default dict wrapped around int will automatically produce a 0 value for you. With counter, the missing method always returns 0. So default dict can be used for other things, like you can default to an empty string, for instance. So it's a little bit more flexible. The other nuance of a difference is that default dict, whenever you access an item, a key that wasn't in the default dict, it automatically creates that key for you and inserts it in the dictionary. So if I look up and say, what is the count of Martians in my set, or in my counter, and there's no Martians there, a default dict would actually create an entry for Martians with a value of 0. A counter, on the other hand, would just tell you that there's 0 there, but it would not create an entry for you. So there are no 0 entries stored inside. Okay. So there's two convenience methods added to this. We just talked about most common. It returns a sorted list of the end highest counts. It's there to handle the most common use case for counter, which is you count a bunch of items and you want the most popular. So you need the most popular news articles of the day, most popular key hashtags on Twitter and whatnot. And it takes a commonly written block of code and reduces it to a simple one-liner. And it's implemented either using sorted if you want the full list, or if you want a subset, it uses heap queue and largest. So another method that's kind of interesting is elements. A dictionary already has an iterator, so if you iterate over that example that we've already covered, what would it give you? It would give you key value pairs. It would return, I have 3 copies of A, 5 copies of B, 2 copies of C. Elements is different. It's another type of iterator that returns the items one at a time. So it would return A, B, 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 C. And so it works more like the bag does in Smalltalk. And so it's a way of accumulating items in your bag. You store only the counts, but when you pull them out of the bag, you can pull them out one at a time. How many thought all of that was completely obvious and not incredibly illuminating? Oh, only a couple people. But let's do something cool with it. Let's do some counter math. Okay. Go, baby. Okay, so we have 2 kinds of counter math. One is regular math, or non-saturating. So regular math, we have 2 methods. We have counter update. So if you take one counter and update it with another, it'll add the 2 counts together. So it's like I've accumulated 2 different bags. I've merged the bags and created a single bag. If you want to undo that operation, you can use count subtract. It has a very obvious implementation where it loops over the parameter that's given to it. It loops over that input counter and then takes each of the counts and adds it on. And likewise with the subtract, it does a straight subtraction. So none of this is terribly surprising. Let's look at an example. We start with a counter with a count of A at 1 and a count of B at 1, and I subtract off A at 1 and C at 1. So A gets reduced down to 0. C's go negative because there were no C's in the initial set, and there's a positive 1 for B, which was in the first but not the second. Regular math. So what other type of math could there be? The other kind is drawn straight out of a Knuth textbook. It's a multi-set use case. If you're viewing your counter as a multi-set of items, a multi-set being, I have a set of objects, no duplicates. But if there are duplicates, we keep the count of them. So we have one element A that occurs 5 times, so it tracks the multiplicity, hence the name multiset. And so the operations are add, subtract, and R. Add does the obvious thing. Subtract is the interesting one. This subtraction operation is called saturating subtraction. It never subtracts below 0. So if you have one element in the set and you subtract 2 from it, rather than going negative, it takes it down to 0 and removes it from the set entirely. So that's saturating subtraction. And you use it. The use case for this type of mathematics is more when you're counting objects and it doesn't make sense to have negative counts. I want to remove all people whose name starts with Z from my count. Well, if there's no people there, it won't take it negative and put negatives in there for you. So in this example, I take 2 counters and difference them at the bottom, and you see that A disappears entirely, C disappears entirely, it does not go negative, and so all that's left is the positive count. And so that's a different result than we got on the different page. So different use cases, 2 different types of math. Regular math, where you can go negative, and saturating subtraction, where you don't go down below 0. On the line, just, I can't see the screen, so I can point at it. On the example, the first row, I'm not using counters at all. I'm actually using regular sets. I'm taking the set AB and subtracting the set AC, getting B. And what that's intended to demonstrate is that multi-sets behave just like regular sets when the counts are all 1. So multi-set operations were really designed to mirror set objects, except that they track multiplicity. And I hope you guys find that as interesting as I did. Who wants to go on to something cool like name tuples? Sweet. All right. A name tuple works just like a regular tuple. But it'll let you assign a name to each field. How much is embedded in that statement? Let you assign a name to each field. That does not sound like an important capability, but it turns out it's a vital capability. It can profoundly change your code base. And I believe that if you were to take one thing from the conference, it would that would be immediately useful. It is to go back home, go through your code base, and find everywhere where you're manipulating tuples by position indexes and replace it with a name tuple. So if you have parts of your code that say, take T3 and put it in position S2, and then take S5 and print it out, and then print S6 to the screen, you have some unintelligible code that is very difficult to follow. In addition, you've created a sequential dependency amongst the elements of your tuple such that later you can't rearrange your tuple easily. So for instance, with a time tuple, each of the fields has a different meaning. And because we originally presented it as a tuple, we can no longer insert a field in the time tuple without messing up everybody's tuple unpacking. We can't change the meaning of field 5. It always has to be. If it's currently seconds, it'll have to stay seconds. But if you're using name tuples in your code, you can go and insert fields later, knowing that all of your client code is manipulating it by name and not by position index. So there would be, to use the time tuple example, you say t.seconds is printed to the screen. Later, if you rearrange that tuple, t.seconds will still be a valid reference, and you won't have to go through your code and find every place you referenced t at 3. And I think it's a fantastic capability, and I want to take this small concept of names assigned to position and really sell to you guys that it's a very important thing, and you can go back home, go search your code and find some immediate use cases for it, make your code more readable and easier to change. So let's look at a simple example that has been extracted from doctest. So if you call up the source for doctest, at some point you'll see a line at the top that says test results is equal to name tuple of test results failed and attempted. And what it's doing is defining a name tuple that says this is a tuple of length 2, where the first field means the number of failed tests and the second means attempted. So if you were running doctest and you do at the end of your test print doctest test mod, you get a nice display to the screen. It says test results, failed equals 0, attempted equals 7. That's easy to interpret. There's a nice repr there. And if you're going to parse those results, you can say result.failed and take some action on it. If result.failed is greater than 0, take some special action. And it makes for readable code. The way doctest used to print is if you printed doctest.testmod and the test mod should have parentheses after it, which it doesn't. It used to be if you printed that, it would just return the tuple 0, 7, which if you hadn't looked it up in the docs recently, it was hard to interpret whether that was a good thing or not. Is that 0 successes or 0 failures? Big difference. See how it makes your code self-documenting? Who thinks name tuples rock? Fantastic. Let's take a look at part of the implementation. Just the it's pretty simple. It's a subclass of tuple. Notice the doc string for that class. It describes that it is a test result object that has failed and attempted second, so they has a self-documenting doc string. There is the slots being empty means that name tuples are very efficient. They don't take up any more space than regular tuples. I said that in a real monotone voice, so it could have just floated right by. Take this part home. The space cost of using a name tuple is 0. If you read in 10,000 lines from your database and cast every one of those input lines, which comes in as tuples, to name tuples, the additional space consumption is 0. There is no cost to wrapping a tuple in a name tuple. There's 0 space overhead. Next line is interesting. The underscore fields, it failed and attempted. Why do we need that? The doc scheme already tells us. Well, it's one of our design principles, which is as much as possible we try and make our classes introspectable. So it's possible to look at retrieve a name tuple and query it and ask it what its fields are, and it will tell you the field names in order. The next section is the creating a new tuple. The fields on that are failed and attempted. And what's nice about this design is if you supply too many arguments or too few, you get the same nice error messages that you would get if you just rolled the class by hand. And had I written this in C, it would be much more difficult to give you those quality error messages. Next line is a representation. And I think you can see from our previous example with the unit test or the doc test results that that representation is nice. It is much better to have than having a 0, 7. It's better to say this is a test result with failed 0 and attempted 8. Okay, and then the last lines are kind of cool. They're a little bit more advanced Python using property and item getter. The takeaway from here is it is a very fast and efficient way for the name tuples to work. It works a lot quicker than an equivalent lambda. And so it gives you almost C speed. And I have attempted to roll some name tuples in C to compare them. And I could beat it in C, but not by much. The takeaway there is they are very efficient. Okay, pop quiz. Name tuples are something that probably should be used in your code base in art. True or false? True. Name tuples have, if you get a long list of tuples back from a query and you cast them each as a name tuple so they can display in a beautiful way and so that their fields can be accessed in a beautiful way, your space overhead is how much? 0. Okay. Is it fast?
Yes.
Yes. All right. So in addition to that simple implementation, I've tacked on a couple convenience methods. Let's take a quick look at those. All right. There is under asdict and under replace. What does the normal under naming convention mean? When you see something in a class that says under asdict or under replace, what does that tell you? Private. Normally it means it's a private method and something you shouldn't touch. That is our one way to communicate in our consenting adults world. Hey, you could get to this, but don't. But we adopt a different naming convention in name tuples. And the reason is the namespace that we would use to put, if I put asdict without the underscore, that namespace is the same namespace being populated by attribute access from your field. So if I were to take the underscore out here, you would never be able to have a field named asdict and never able to have a field name replace. Now, of course, you guys wouldn't name those fields that, but name tuples can be used with fields that are given to you by an external source. A lot of times in a CSV file, the top row lists out all of the header fields, and they can be cast into a name tuple. In other words, it's data-driven. externally data driven what the field names are going to be, and so potentially there would have been a name conflict here. So that is our technique for resolving that conflict, and the module documentation is very clear that that is something that is done for name tuples and for nothing else. Okay, asdict takes that test result and turns it into a dictionary with the key failed is 0, attempted is 7. Why do we need this? What was the use case for it? Usually I demand a lot of use cases before I put a method in on a class. But in this case, we had a design principle pushing us there instead. And I think it's a design principle that you can apply widely. And that is, whenever you have any kind of object that does anything, if it has keys and it has values, key-value pairs, no matter which context they're in, I think a good design principle for Python is whenever key-value pairs occur, you should be able to convert from a dictionary into a dictionary easily. And so this gives you a way to turn into a dictionary. Because we have field names, and we have, my goodness, 10 minutes left, we got a long way to go. All right. Important design principle. Got key value pairs anywhere, be able to turn it into a dictionary, or be able to take a dictionary and get it in. This goes for something like config.parser anytime you have the two paired together. Replace is kind of nice. It's an interesting method. It takes a tuple, loops over, keeps all of the fields that were there, but then when you specify that one field needs to change its value, it rewrites it and creates a new tuple for you. So in this case, if I change the test result to failed at 2, notice the attempted 7 passes right through, but the failed field upstates. And that is much cleaner than the traditional style where who has written code like the final example where you say, I've taken the result, wrapped it in a little tuple, added it on to part of the result, and probably had to use string slicing or tuple slicing along the way. Who's written code like that? Who thinks it's ugly? All right, who wants it to go bye-bye? All right, here's the way. All right, those are the basics. Who wants some pro tips? All right, you came for the good stuff. All right, using the field structure. Do you remember that under fields attribute? It tells you the field names that are in the name tuple. So you can use one name tuple to define another one. So let's say we already have the test result. I don't have to go back in and type its field names again. I say test result.fields and then add on a new one, test name, and I've created a new name tuple category called a labeled result. So I've gone from test results to a labeled result, one that has an additional named field. And you can very quickly build up a nested structure that says a color consists of an RGB value. A point consists of an XY position. Now I have a colored point, which is the two sets of fields put together, and then I can add on to that an extra coordinate and go from X and Y to X, Y, Z and have a 3D colored point. And you see how these compose very nicely. Next pro tip. Instance prototypes. This is a cool way of programming. How do you get default values? The answer is take your name tuple and create one instance with all of the fields populated. Let's say in this case I have a cell name tuple that has 3 fields, a color, a size, and a border. And I create one prototype instance with all the default values. My default is red, my default size is 10, my default border is off. Now, when I make specific instances, instead of making them from cell, I just clone from the prototype. So I say prototype replace size 20. Now intro has size 20, but it also has color red and border equal false. The lead will replace the color with blue and the border true, but the default size will come through. Who learned something new and cool? Fantastic. Okay, and another pro tip. How to extend its capabilities. Remember, all it's doing is generating a class, so you can subclass from it. So don't just assign the result of a name tuple, use it in a class definition and subclass from it. One caveat is you might want to start by setting the slots to empty slots, because slots don't inherit. Every time you inherit from a class that has slots, you need to redefine them. That'll make sure that you don't use up any extra space. We like that 0 overhead. And so here we've taken the point tuple and we've replaced its ripper so that we get a nice pretty table format, and we've added a method, a property rather, hypotenuse that can compute from the other points in the tuple. So it's a nice way to add some computed fields. You know, in SQL, you have fields that you pull down from the database, but you also have computed fields that can combine results from those. And this demonstrates that technique. And so you can see that even though the point inside has only 3 and 4 for x and y, it can also print out the hypotenuse, and the formatting can be controlled. So this is a fantastic technique for start with a name tuple to define what your attributes are. But go ahead and feel free to subclass it and start adding methods onto it to extend its capabilities. Who learned something new? Fantastic. And I should call the next one an anti-pro tip. Python is a dynamic language, so we shouldn't program it like a static language. In static languages, we've come to love enumerated types. We've got them in C, we've got them in Java, they appear all over the place. So when someone comes from one of those languages, one of their first projects is they say, I would like to create an enumerated type. I missed it. I don't think you should. We don't need them. We have lots of ways to do that in Python. We can, if you look at opcode.py, you see that we just use the module namespace. That's one way to do it. You can tuck things in a dictionary, or you can tuck them in a class. But if you would like to use name tuples to do it, you can define, let's say, a color enumeration. The various fields of the name tuple are positions that you will then populate using make and put in range 6 so that 0 gets assigned to red and 1 to orange. Now when you put color.red, you get 0, and color.3 is green. So who learned something cool? Who knows that you shouldn't do it because we don't need these such things in Python? Oh, fantastic. Okay. Don't go proposing it on Python dev tomorrow and say, hey, I think we need an enumerated type, and I know exactly how to do it. Bad, bad, bad. All right. Next cool thing is caching. So this is, what I'm showing on the screen is Python's usual idiom for writing a cache around a function. You create a cache variable. Every time the function is called, you check to see if the argument's in the cache. And if it's already there, you return it. If it's not, you call your big computation that you were going to do anyway, take that result, store it in the cache, and return the result. Very simple Python code. Who likes to write that over and over again? No one. Who? Oh, okay, one person. Who would like to have that collapsed to one line? Okay. Who sees a problem with using this style? Fantastic. We have a lot of long-running processes, more than we did in the early days of Python. You're running Django. You don't intend for that process to die. It's a long-running process. We have lots of things like that now that we fire up servers and whatnot, that we turn them on. We don't tend to turn them off for a very long time. The problem with this cache style is it grows without bound, and eventually it will eat up all available memory and then fall over and die. Not good for your server. What to do? An LRU cache. Let's make the cache of a finite size. Let's say 100 items. And as new items come in, we will bump the old items out. Which one should we bump out? A popular strategy is to age them in order of access so that recently used items stay in the cache and infrequently used items get bumped out. So the one that gets bumped is the least recently used, hence the name LRU cache. How hard is it to use? You see pretty much all the code for it below. You import it, and then you wrap it as a decorator in front of your function, and presto, you get caching for free. All right. Now notice the max size equal 100. That specifies the size of your cache. You can never get bigger than 100 items. What happens if you specify max size 0? It goes back to the recipe that we had on the previous page so that you can get, instead of all of that internal structure that tracks recency of usage, you can have a cache that grows without bound. So I think it has an obvious use case. Before I go ahead, I want to make sure you know that use case, which is when you have a long-running process and you need a cache, it takes one line to add a cache to it, which I think is cool, but it's a finite size, and so that your memory won't go without bound. Who has an immediate use case for that? Fantastic. If you're not on Python 3.2, the code is not that hard to cut and paste. You'll need to cut and paste the code for ordered dict, which it's based on. So ordered dict and LRU cache go hand in hand, but they backforce very easily, and I've got a recipe for it on the Active State Cookbook. So just search for my name and LRU cache, and you'll get a link to the backported version, so you can use it on older versions of Python. Okay, we've discussed the obvious and important use case, but is there anything cool we can do with it? Yes, dynamic programming. All right, you have a poorly programmed Fibonacci function. Poorly programmed because it's inefficient. Each call, if you do run this with Fibonacci 100 without the LRU cache, it won't finish in your lifetime. because the call at 100 spits out a call to 99 and 98. 99 splits back out to 98 and 97, but it doesn't remember that 98 has already been called, and so it just sprawls out in a fairly huge manner that kills your machine and runs forever. You can improve this code by just putting the @LRU cache in front of it, and it caches all of the results. Now if I say print Fibonacci 100, it makes 101 calls to the Fibonacci cache, which I think is the Fibonacci function, which I think is fantastic. It takes it from something that won't finish in your lifetime to something that finishes in milliseconds. Who thinks that's cool? All right. So next time somebody asks you about, you go to apply for a job, a favorite question is to present you with a dynamic programming problem. The impressive answer is to write a non-dynamic answer like the Fibonacci sequence here, that it's described as it would be in a math textbook, not as it's done in programs because it's inefficient, and then just wrap an LRU cache in front of it, and it's efficient and dynamic. So that becomes your cool answer to a problem that was meant to be hard. All right. How am I set for time? Out? If I keep talking anyway for 3 minutes, will anybody shoot me? All right, new string formatting syntax. Okay, I will skip the motivation for it. Rest assured there were some problems with the old syntax. There was people forgetting to put the S after a named lookup, %name S. There was problems with the operator precedence of the mod operator. No good. So this style, the example at the top of the page, we reference the first argument with braces and a 0 inside, and braces 1 for the first two arguments. That one's simple. You can also reference them by name, so brackets page and brackets line to pull the elements out of a dictionary. Very easy to use. One of the options is to be able to specify the fill, alignment, and width, and you'll see examples here. So you put a :8 that says the width is 8, and so that 12 slid to the right. I put a angle bracket 8, and it left justifies it. Caret 8 centers it. If I specify a fill character before the center, I get a fill character, and I can wrap it in number signs. So you have complete control, formatting control over string centering and justification. And very last slide, 0, width and precision for numbers. So it's got your what you're used to with the 8.2F, the same things that you get with the current % formatting, but we can also put a 0 in front of it to make it prepended with zeros and the sign of +0. At this point, you're seeing nothing new, something you've already got. But if you look on the next one, I've added something new to the formatting operation. I put a comma in there. What does that do? It adds a 1,000 separator to your number, which I think is kind of cool. Now, if you're a scientist, you probably don't care about such things. If you're coming to Python from finance, your first immediate aggravation is Python doesn't print numbers with commas. In fact, it's kind of hard. It becomes one of the first recipes you write. Who has missed having commas in Python? Fantastic. All right, questions, suggestions, comments, or complaints? Harold?
Yes. What is the best way to use the new string formatting if you want to output JavaScript? Because JavaScript uses that braces for other things, and it looks really ugly if you double them or escape them.
I understand it. I don't think that we have a way to change from braces to non-braces in that formatting. We do have in the string module a template, and template lets you alter what the delimiter is so that you can use angle brackets or double square brackets or whatnot. But I can't think of a way offhand to do that with the new formatting. Excellent question.
And do I understand it right that counter is not a true multiset?
Counter is a dictionary, and you can do anything you want with it. I have supplied some multi-set methods so that you can create a counter that has negative entries, or zeros, or even fractional or decimal.
Well,
but if you use it as a set, we do provide true multi-set operations.
A true multiset would allow to have distinct objects with the same hash.
In that sense, no. We stick with the Python definition of a set. So all members of an equivalent class grouped together.
And another question is, what was the rationale in accepting a space-separated string in the name tuple constructor when you can always do just dot split?
Right. So it's interesting. The name tuple constructor lets you take a string x, y, and it splits it for you. One is if we put too many obstacles in front of a person, people stop using it, or it's an amazing number of people who would trip over that. A common use case for named tuples is if you're doing, let's say, a SQL query, you can cut and paste that SQL query and put it in to the named tuple, and it will parse it for you. Then later, if you go and change it, you can do that cut and paste again. So we support 3 different signature styles, and pretty much use whichever one is comfortable for you, and it will just work right out of the box. And part of your answer is also that I've tested this by putting it in a number of people's hands and found out what was convenient for them and what worked. And that was a style that looked clean and was something they happened to enjoy. And when we had the dot split in there, it interfered with the person's ability to read the line and determine what the name tuple was doing, because you've got 2 operations in one line.
Thank you.
Yes. Okay.
I have a very quick question.
Okay. I'm going to do 1 minute, our last question,
Okay.
and then we'll move to an open space.
So what storage backend does the LRU cache use?
Oh, what storage? What?
Yeah, how do you achieve the caching in the LRU cache? Is that
Okay, I use a dictionary, an ordered dictionary, and the ordered dictionary has 2 regular dictionaries in it and a doubly linked list. The doubly linked list remembers the sequence order. The outer dictionary references into it so that it can pick an item based on a key.
And what's the key that goes into the cache?
What is the key? The key is the positional args plus the keyword args with the keywords in sorted order.
Thank you.
Yes. Okay, thank you very much. I hope you loved it. Twitter, Raymond H.